Definitely want to memorize the distance formula as you get ready for the written test that we'll take in a little bit. Not tonight, obviously. How many? What? A month? What's the official date of the midterm exam? The 28th. Okay, so not quite a month. 3 weeks. Right. Not to stress anyone out. I probably shouldn't have mentioned it. Sorry about that.
You're going to give me a heart attack.
Okay, but in the spirit of feeling better about the test, let's say be sure and memorize. Pen color is what I want. That one. D equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Square root of the sum of the squares of those differences, and that will tell you the distance between 2 points on 2 points at the end of a line segment, the length of the line segment. So here, take either one of those ordered pairs, call it x sub 1, y sub 1, maybe this one, call that x sub 1, y sub 1, call the other one x sub 2, y sub 2, and then D equals the square root of the x's first, 1 minus 2. That's going to be negative 1, and negative 3 minus 0. So we're going to square that negative 1, and we're going to square that negative 3, and add those squares. 1 plus 9. So the square root of 10. It wants an exact answer using radicals as needed. So I'm thinking the square root of 10. Should make it happy. Square root of 10? Yeah. Okay. Not too bad. But it didn't give me a green check mark. Save. There we go. What? No. The midpoint. Oh, the midpoint formula. You want to make sure that you know that one too. Midpoint formula. Didn't leave myself room for it. Midpoint formula. X sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. If you have a whole bunch of numbers, and you want to find the average of those numbers, how do you do that?
The average, don't you add them together and divide by the amount of numbers that you have?
Amount of numbers. Add up all the numbers and divide by however many numbers there are. So what if we have 2 numbers, and we want to find the average of those 2 numbers?
Add them together and divide by 2.
Add them together and divide by 2. That's what you're doing with the midpoint formula. Find the average of the 2 x coordinates. Find the average of the 2 y coordinates. So add the x coordinates together, divide by 2. Add the y coordinates together and divide by 2. Let's take a peek and see what those x and y coordinates were. It was 2, 0, 1, negative 3. So add the x coordinates together. 2 plus 1 and divide by 2. Add the y coordinates together. 0 plus negative 3 and divide by 2. And if we like fractions, that's 3 halves, comma, negative 3 over 2. Sometimes when it says it'll only accept fractions, it may accept decimals, but to be safe, we should probably give it fractions. Let's see what it did say. Type an ordered pair, simplify your answer. Should we throw caution to the wind and use decimals and see if it likes it? What do you think? Maybe not. It was
repeating, so
positive 3 halves, negative. Yeah, I wouldn't. If it were repeating decimals, I would not use repeating decimals because you have to round and it's inexact and it's probably not going to like that at all. It might not like this at all, but it didn't specifically say fractions. So I'm going to roll the dice here and go with that. Yeah. Sometimes it will specifically say fractions in lowest terms, and then it might not like the decimals, even if they're nice, friendly, terminating decimals like these are. But I think this will be okay. All right, hopefully this is a nice one that we feel reasonably good about. Problem, what? Did I click save? 4 look just the same. Let's look at 5. Don't care for this one at all. Could show up on the quiz, though. It's just a matter of dealing with the decimals. I think when we do the subtraction, though, it ends up not being all that bad. You run into this one on the quiz? Or on the homework, I guess.
I I ran into it on the homework, and I don't think I've passed this question yet.
Not
And
yet.
The decimals did kind of go away when you subtracted, but I still couldn't get the right answer.
Let's give it a look. All right. So find the distance between the 2 points and the midpoint of the line segment. I'll try not to forget the midpoint this time. D equals the square root of, there's my y sub 1 and y sub 2, x sub 1 and x sub 2. So difference in the x's, 6.6 minus 1.6, and we'll square that difference. Difference in the y's, 7.9 minus 3.9. So the coordinates themselves aren't terribly nice. They're not nice whole numbers, integers, but the differences between them are integers. D equals the square root of 6.6 minus 1.6 is 5, so take the 5 and square it. 7.9 minus 3.9 is 4, so take the 4 and square it, and we get the square root of whatever 25 plus 16 is.
41.
The square root of 41. And 41 does not have any perfect square factors, other than 1, obviously, so nothing we can use to simplify it. So the square root of 41 should work for the distance there.
Oh, question. Did you say at the beginning that you were, when you were writing these out, you're putting them on that other, are you posting that on your website?
This particular video recording, or the printout, like that you can print out the page?
Yeah, like where you're actually writing.
That's a good question. The midpoint. Let's average the x coordinates and average the y coordinates. This is probably just a slightly more of a strain than the distance formula was, because we won't have integers in this case. So take the 1.6 and add it to the 6.6, divide by 2. Take the 3.9 and add it to the 7.9 and divide by 2. Sometimes I like to do this. I don't know if it would help me in this case, but try to think what number's halfway in between these numbers. Might not be helpful at all. Probably just better to pull out a calculator. So if I added these together, 7, what's that? 8.2. 8.2 over 2. And if I added these together, 11.8 over 2. So divide by 2, 4.1, and 5.9. Thank you. So 4.1 comma 5.9. This would be the midpoint of that line segment with the stated endpoints. 4.1 comma 5.9. More of the same? Yeah. So let's go ahead and look at 2.2. Yeah, I'm not sure why quiz 4 showed up way up here. I need to reorder the quizzes. The due date is 2/15, so hopefully that won't scare anybody that it showed up that high. Quiz 3 is definitely the one, if you've not already finished it, that you want to have your mind on the next 24 hours, I guess. 2.2. 2.2 was about a little bit about x and y intercepts. I don't know that I say a great deal about x and y intercepts in the actual videos. The main emphasis is on symmetry and finding x-axis symmetry, y-axis symmetry, or origin symmetry. But the intercepts, we'll go ahead and work through these problems without sketching the graph. Find the x and y intercepts of the graph of the equation. Real standard procedure for finding an x-intercept. You know, an x-intercept is going to be a point on the x-axis. All the points on the x-axis have 0 for their y-coordinate. So we substitute 0 for y, solve for x, and we find the x-intercepts. So we let y be 0, and then substitute 2x plus 5 times 0 equals 30. 2x plus 0 equals 30. And so 2x equals 30. What's x? 15. Divide both sides by 2, x equals 15. So the point that one would plot, if it happens to ask us to graph this, would be the point 15, comma 0. Official definition, I think, of an intercept is a point where the graph intersects the x-axis or the y-axis, and so we need both the x and y coordinates. A lot of times, though, it will just ask for the x-coordinate. Question, yes? It just wants the 15. Yeah. So we'll put that in there. 15. Just the one x-intercept. If there were multiple x-intercepts, it would one commas in between them. But just the one, evidently, it just wants the 15. Y-intercept. Let x be 0. Y-intercept's got to be a point on the y-axis, and all the points on the y-axis have an x-coordinate of 0. So let's see what y value we can pair with that to make it true. And 0 plus 5y equals 30. 5y equals 30. Y equals 6. So, yes, I'm going to write the point 0, 6, but it's just going to want what? Just going to want me to type in the 6. And although it saddens me because I like to think of intercepts as points rather than just numbers, I think textbooks do officially define if you specify that it's the x-intercept, it's the x-coordinate of that point on the x-axis. If you specify the y-intercept, it's the y-coordinate of that point on the y-axis. And if you just say what are the intercepts, that's when you have to indicate both the x and y coordinates to indicate to the observer, is it an x-intercept or a y-intercept? If you just tell a number, it's it's impossible to know. Problem 2. Without sketching the graph, find the x-intercepts and y-intercepts. Well, just one y-intercept, but a couple of x-intercepts, I believe. X-intercepts. Let y be 0. 0 equals x squared minus x minus 6. And then it's a factoring problem. Feel comfortable factoring this? 3 and 2. And opposite signs, bigger one negative to give us the minus x in the middle. So an x and minus 3 and a plus 2. Negative x in the middle, negative 6 on the end, and x squared in front. So set each factor equal to 0. And we can see what the solutions are. 3. If you substitute 3 for x and 0 for y, it makes it a true statement. If you substitute negative 2 for x and 0 for y, it makes it a true statement. So the points on the graph are 3, 0, and negative 2, 0 that I write in my stubbornness. But I guess just the numbers there, the x-coordinates, are going to be what it wants. The x-intercept separated by, does it say separated by commas? Doesn't, but it probably should. Where does it say separated by commas?
Perhaps separated by / because they say it is /r.
Yeah,
Commas. Okay, 3, negative 2. Let's try that. 3, comma, negative 2. There. Oh, funny. 2 x-intercepts, it doesn't bother to mention the commas thing. Just one y-intercept. Separate the one y-intercept by commas as needed. That's when I'm supposed to send. Where is it? What? There should be an Ask the Publisher link there. I'll figure that out later. This one's an easy one, though. For the y-intercept, just let x be 0, and y equals 0 squared minus 0 minus 6.
-6.
So everyone feel good about -6 there. Just the -6. No comma necessary. Got it. Okay. So hopefully that one is not too bad. Symmetry. There are 3 types of symmetry that we're interested in this section. In the videos, I gave 2 general types of symmetry: symmetry with respect to a line, symmetry with respect to a point. But basically, it's the 3 specific types of symmetry, the 2 lines that we care about, the x-axis and the y-axis, and the 1 point that we care about, the origin. So those 3 specific types of symmetry, and there's a test for each one. If we're testing for symmetry with respect to the x-axis, and I'll go through all 3 of these in this case, then we're going to want to substitute negative y for y to see if it makes, see if it gives us an equivalent equation. So the graph of this one is actually going to have what type of symmetry? Anybody know just by looking at it? X, Y, origin, none of the above. If it were to have x-axis symmetry, then the graph could possibly look something like this and that. It turns out not to, but if it did, it could possibly look something like this. This would be an example of a graph that had x-axis symmetry. If you had a point on that graph, x comma y, and you march directly toward the x-axis and out the other side, then what would be the coordinates of the image of that point with respect to the x-axis? X negative y. So if we're looking at the equation, whenever the ordered pair xy satisfies the equation, the ordered pair, well, the point x negative y would also have to be on the graph, so x negative y would also have to satisfy the equation. So what happens if we substitute negative y for y and it has x-axis symmetry, we can simplify and obtain an equivalent equation. So let's try that. If we're testing for x-axis symmetry, we substitute negative y in place of the y in the original equation. Simplify, really we lose the parentheses, and that's all the simplifying that we can do. We look at it, we ask ourselves 2 questions. Question number 1, is this equation identical to the original equation? The answer is no. We've got a negative y where we had just plain old y before. Second question, is there an algebraically legal maneuver that we can perform on this equation to make it identical to the original equation? Basically, and the answer is no. Basically, there are 2 typical algebraically legal maneuvers that we have to choose from. Algebraically legal maneuver number 1. We can multiply both sides by negative 1. That will generally fix a negative sign, but sometimes it breaks others, and so it doesn't work for us in this case. If we have a fraction, an algebraically legal maneuver that would give us an equivalent fraction would be to multiply both the numerator and denominator of that fraction by negative 1. And sometimes that'll give us back the original, even though it doesn't, the simplified version doesn't look like the original. Nothing going to make this look like the original, so this is a no. This does not have x-axis symmetry. Now, it could have y-axis symmetry. An example of a graph that might have y-axis symmetry, and I think this one is going to look something like that. Rough-looking parabola there, but that's the idea. If we have a point on the graph, x, y, and the graph does have y-axis symmetry, if we march directly across the y-axis out the other side, the same distance, what would be the coordinates of this point?
Negative xy.
Negative xy. Same y, opposite x. So if xy is on the graph, negative xy has got to be on the graph. So if xy satisfies the equation, negative xy has to satisfy the equation. So if we substitute negative x for x, let's do that. y-axis. Substitute negative x for x wherever we see an x, and simplify. This needs to be equivalent to the original equation. Now this is a tough one. It's a question that about 5 out of 10 college algebra classes will struggle with. My class, my 9:30 class, what time does that class meet? I think it's 9:30. This semester struggled with this a little bit, so let's try it in here. What is the square of negative x?
X squared.
X squared. Negative x times negative x. Negative times negative is positive. X times x is x squared, so positive x squared. So y equals x squared plus 2. Question number 1. I think it's the only question we need. Is this equation identical to the original?
Yes.
Yes. If it's identical, then it's equivalent. So this graph, or the graph of this equation, will have y-axis symmetry. So this is a yes. Now, it turns out that there are only 5 cases that we have to consider for these 3 types of symmetry. There's x-axis symmetry only, y-axis symmetry only, origin symmetry only, all of the above and none of the above. It turns out that it's not possible for a graph to have exactly 2 out of 3 of these types of symmetry. If we start with a graph that has one of these types of symmetry and we try to add something to it by reflecting it about an axis or about the origin so that it has a second of these 3 types of symmetry, it'll automatically pick up the third. It's not possible to have exactly 2 without the other. So, is it possible that at this point this graph could have origin symmetry? It is not possible. So it's going to be a no for origin symmetry, but just for completeness here, if we're considering what a graph would look like to have origin symmetry, well, what might have origin symmetry? Something like this and that, where the origin is the middle point on the graph. If you take a point here, x, y, and you march directly through the origin out the other side the same distance, what would be the coordinates of its image about the origin?
Negative x, negative y.
Opposite x, opposite y, very good. Negative x, negative y is what it would be. So, to test for origin symmetry, we substitute negative x for x and negative y for y at the same time. And if we do that here, we'll have negative y equals negative x quantity squared plus 2. We lose the negative on the x because we're raising it to an even power. So we get x squared plus 2, but just plain old negative y. This is not equivalent to the original. If we multiply both sides by negative 1, that's not going to be equivalent to the original. So this is no. And so it's y-axis symmetry only. That is.
So you're saying that if you have, the only way to have the origin is if you have x and y both?
If you substitute negative x for x and negative y for y at the same time, and somehow it gives you back the original equation, then that would have origin symmetry.
Okay.
Yeah.
I meant if you've got, because we've got no and yes, I'm wondering if origin, if you've only got one of the other 2,
Mm-hmm.
can you still have origin?
Oh, I see what you mean. If you have exactly one of the other 2, then you will not have origin symmetry, because that would give you 2 out of 3. Suppose it's not x, but it is y. You know it's not origin, because it can't have both y and origin. What if you have both x and y?
Mm-hmm. Then it's origin.
Then you can have origin, because you can't have the first 2 without the third.
Okay.
Yeah. So if you know something about x-axis and y-axis, in most cases you'll automatically know something about the origin symmetry. What if you test for x-axis symmetry and it's a no, and you test for y-axis symmetry and it's a no? Then what do you know?
It's not an origin.
I guess there's still 2 possibilities, huh? It could be origin symmetry only, and neither x nor y, or it could be none of the above. So you still have to test for origin symmetry in that case. So sometimes we can skip the origin symmetry test, other times we have to check for it. Got to skip it in this case. Y-axis only. 4. Let's see. Oh, wow. Any thoughts? What's the question? Is it symmetric with respect to the x-axis? Well, if you substitute negative y for y, the right-hand side really doesn't change. The left-hand side, you've got a negative y. I'm going to say no. Not symmetric with respect to the x-axis. But I'll go ahead and go through the motions here of checking for symmetry with respect to the y-axis. To check for symmetry with respect to the y-axis, substitute negative x for x in both spots there. So it's going to be y equals negative 6 times negative x to the 6th power plus 5 times negative x to the 4th power. All right, does this have to be done in gory detail? I don't think so. I think it should be clear. Negative x times negative x times negative x times negative x. This ought to have what? Sign. Positive. And then, so positive x to the what power? If I multiply these two together, that would be x squared. These two together, that would be x squared. And then these two together, x to the 4th. I think that's easy enough to believe. If it's an even negative sign, or it's a negative sign raised to an even power, we should get a positive sign. So y equals negative 6 times x to the 6th power plus 5 times x to the 4th power. Really don't need the parentheses, but put them there for emphasis. Is this equation identical to the original? It is. This is what we started with. So this is a yes, again, for the y-axis symmetry. And if it's a no for x and yes for y, what can we say about origin symmetry? It's a no. Can't have two without having the third. All right. I did not mean to do that. Question 5. What do you think here? No for the x-axis symmetry. If we substitute negative y for y, we're just going to have negative y equals 4x cubed plus 8x to the 5th. And that's not going to be the same as the original. Multiplying both sides by negative 1 is not going to make it the same as the original. So I agree. That's a no. How about y-axis symmetry? Substitute negative x for x. This is also going to be no. I feel like I should write a little bit more for this one. A little bit more for this one. This much. Y equals 4 times negative x to the 3rd plus 8 times negative x to the 5th. Now, negative x times negative x times negative x is going to simplify to equal what? Negative x. And we have 3 of those x's there multiplied together. So negative x to the 3rd power. Likewise, negative x raised to the 5th power is going to be the negative of x to the 5th power. 4 out of 5 negatives multiply together to make a positive, but that 1, that 5th negative, well, sticks around. So y equals negative 4x cubed minus 8x to the 5th. Is this identical to the original? No. If I multiply both sides by negative 1, is that going to make it identical to the original? It's going to fix the minuses on the right. It's going to mess up the y on the left. So no. So this is also a no. I guess I should check it, right? Green check mark rather than filling it in. That's a no. Is it symmetric with respect to the origin? Well, it's a no for the x, it's a no for the y. It's still an open question. It could be origin symmetry only, or it could be none of the above. So we still have to check it. So let's check the origin symmetry. Origin symmetry, substitute negative y for y and negative x for x at the same time. Now we know how to simplify the right-hand side. When we simplify the right-hand side, we just did that. We got negative 4x cubed minus 8x to the 5th. And then we're going to have a negative y. Question number 1, is this equation identical to the original? We have minuses here. We had pluses in the original. The answer to that would be no. It's not identical. However, is there an algebraically legal maneuver we could perform on this equation to make it identical to the original? And the answer to that is yes. We can multiply both sides by negative 1. And when we do that, we get the original. That means it's equivalent to the original equation. And if substituting negative x for x and negative y for y at the same time makes it an equivalent equation to the original equation, then the graph has origin symmetry. So that's going to be a yes. And we'll put a yes. A quick peek at the graph of this. Y equals 4x cubed plus 8x to the 5th. Let's see if it even looks like it has origin symmetry. I'm thinking maybe not, in that the graph probably is going to look a lot like that. I don't know what that what that was the graph of, but again, 4x cubed plus 8x to the 5th may actually not be worth our time, but I'm going to sketch it anyway. Zoom 6. Okay, there it is. It has points here in the first quadrant, points down the third quadrant, and if you march from a point up in the first quadrant straight through the origin down into the third quadrant, the image of that point will be there on the graph. So this graph does have origin symmetry. For future reference, that's what it looks like. I don't know where I'm going to put it. Let's put it. That's a good spot right there. Good enough. All right. Okay, I think 2.2 Part 2 has those instructor-created questions. Is that right? Yes. Sorry about that. Well, not sorry that they're there. I'm sorry that you don't have the, show me an example active feature. That's what I'm sorry about as far as that goes. Here we go. Yes, I made these up myself. I am, got to tell the truth. Test the equation xy equals 7 plus 4x squared for symmetry as indicated below. It just seemed kind of unsatisfying only to have multiple choice questions in this genre of question. So actually substitute negative y for y and see what we get. Well, how much simplifying? A little bit of simplifying, I guess. What we'll have to do is this. We have to substitute negative y for y, and then what's x times negative y? That's really all the simplifying that has to be done. X times negative y, negative xy. Negative xy equals 7 plus 4x squared. So we type that in. That's what goes in the box. Negative xy equals 7 plus 4x squared. Okay. And I have to wait, I guess, to see if I got it right or wrong. Does the graph of the original equation have x-axis symmetry? Is this equation equivalent to the original? It's not. I can't make that negative sign go away without messing up the right-hand side, so that's a no. So we move on and test it for x-axis symmetry. So to test for x-axis symmetry, we will substitute negative y for y. Sorry. Okay. My bad. I apologize. It did not have x-axis symmetry. We move on to test for y-axis symmetry. To test for y-axis symmetry, we substitute negative x for x. So that's negative x times y equals 7 plus 4 times negative x quantity squared. Two places the x shows up in this equation, so substitute the negative x for x in both spots. Negative x times y equals negative xy. And if we square the negative x like we've been doing, we don't get that. We get x squared. So 4x squared. This is the same equation basically we got when we were testing for x-axis symmetry. Still not equivalent to the original. Still have to type it in though. So type it in. And what do we conclude when we were testing this? It does have the copy and paste feature. Was that the conclusion? Did I test that in this class?
Yes.
Copy, paste, and still no. So test for origin symmetry. We'll test it for origin symmetry. We will substitute negative x for x and negative y for y at the same time. And what's negative x times negative y? xy. So xy equals 7 plus 4x squared. And that is the original. I guess I can paste it and edit it. Paste, but lose the negative.
Yes.
And yes. It does have the origin symmetry, so check it. So that's the idea with that one. Just to simplify it, make sure that you clear all the parentheses, and then it should be fine. Might be kind of tedious if these others are very similar to this. Xy squared equals 9 plus 6x, and let's compare that with number 3. 3 minus y equals 2x squared. So would you like to see number 2, number 3? Neither or both? Both. Neither. Number 3. Okay.
Hold on. Are we answering your question?
Yes.
Oh, I thought you were asking if you wanted to do the questions.
Let's look at problem 2. We've got xy squared equals 9 plus 6x. Does it have x-axis symmetry? What do you think?
Yes.
Substitute negative y for y. When we square the negative y, we get the y squared right back. Xy squared equals 9 plus 6x. And I'm thinking, yes, this is going to have x-axis symmetry. So let's type the original equation there. X, y. Let me do that? Yes, it will. Good. Xy squared equals 9 plus 6x. And we will say yes. So either it has all of the above, that is, it has x-axis, y-axis, and origin, or it just has x-axis symmetry. So let's see if it has y-axis symmetry. Substitute negative x for x. Negative xy squared equals 9 minus 6x. It's not identical to the original. What if we multiply both sides by negative 1? What would that do? Xy squared equals negative 9 plus 6x. I mean, I'm pretty sure that when I indicated, it's a definite no, but I'm pretty sure that what it's going to be looking for is this. I'm just wondering if I type in the other one, if it'll count it wrong. If it does, it won't tell me why it counted it wrong. It'll just leave me wondering. So to be on the safe side, let's just type what I think it's looking for. Negative xy squared equals 9 minus 6x. and tell it no. Testing for origin symmetry. If we substitute negative x for x and negative y for y at the same time, I want to see if we get that again, don't we? Negative x for x and negative y for y at the same time, negative x times negative y squared equals 9 plus 6 times negative x y squared equals 9 minus 6x. So again, probably we can take advantage of the copy and paste feature. Or just type it in again. Again, that's a no. And that's what it's looking for there. Having done problems 1 and 2, is it kind of clear what to do with problem 3? Or should we look at that anyway? What do you think? Just move right on to problem 4? Yeah, evidently there's an instructor-created step-by-step guide to this problem. So let's move on to problem 4.
No, I brought that up tonight, and it didn't show the writing as you wrote.
It didn't?
I think that's
Unpause. Determine the symmetries, if any, of the graph of the given relation. What do you think? To see if it's symmetric with respect to the x-axis, we would substitute negative y for y, but when we do that, square the negative y, we get the y squared term right back. So it looks like it has x-axis symmetry.
I think it's all.
You think it's all the above? It doesn't give us an option for y-axis symmetry only. It looks like it does have y-axis symmetry because if you substitute negative x for x, you get the x squared term right back. So it's going to have y-axis symmetry. And if you do it both at the same time, they really don't have any impact on each other since they're in separate terms. So it has origin symmetry too. Have we talked about circles yet?
Not really.
We haven't officially talked. They show up later in this section. This is the equation of a circle centered at the origin whose radius length is, anybody know? The square root of 6. Square root of 6. So this is all the above. Draw a complete graph so that the complete graph, after you've drawn it, has y-axis symmetry. So we would want to reflect this about the y-axis. Here's the integrity graphing tool. This point gets reflected over here. This point gets reflected over there. So it should look like that. That'll have y-axis symmetry. And which picture looks like that? Oh, I should have used red. So I'd say all right. Provided we can get through problem 3, that one was short and sweet. Short anyway. And 2.2 part 3. This must be the circles section.
Yep.
Determine the center and radius length of the circle described by the equation. A quick look at the standard form of the equation of a circle. You don't technically have to know where it came from. You just need to memorize it and be able to use it. I'd like to see the connection between the equation of a circle and the distance formula. So quick look. Basically what I do, and I hope you've already looked at this and seen it in the video. If you've got a circle, there we go, and the center of the circle is denoted by HK, and the distance from the center to a point on the circle is denoted by R. That's the length of a radius of this circle. Then we could use the distance formula. Let's say this is an arbitrary point on the circle, x comma y. Use the distance formula to write an expression for the distance between hk and xy. What we do is we say hk is our x sub 1, y sub 1, and our xy is our x sub 2, y sub 2.
So in a sense, you're kind of like finding the midpoint of a circle?
Well, using the distance formula to find, just say for xy to be on that circle, it's got to be exactly r units away. It could be R units down here or R units all the way around there, but it's got to be exactly R units away. So we write out the distance formula. It's going to be x minus h quantity squared plus y minus k quantity squared. And we take the square root of that, and that's, ooh, it's not d. I guess that what I was intending to do was write the actual distance formula, but d is being denoted by r. R equals that distance. Now, we'd rather not have a radical. We could actually use this as the standard form, but it's awkward to have a radical, so we square both sides to get rid of the radical. And then we'll have r squared equals what we get when we take x minus h quantity squared plus y minus k quantity squared and square it. Two things happen here. We lose the radical sign, we lose the exponent. So we have x minus h quantity squared plus y minus k quantity squared. But typically when you see this, the standard form of the equation of a circle, the r squared shows up on the right. So I'm going to scoot it from the left over to the right, and that's what we have. Again, you don't have to know where it came from, but you do need to memorize this and be able to take information about a circle and write the equation, or take the equation of a circle. If it's not in standard form, put it in standard form and look at it and get the h, the k, and the r from the standard form of the equation of a circle. Let's try this with this problem. Determine the center and radius of the circle described by this equation. So the thing to remember about the standard form of the equation of the circle is the minuses. There's a minus in front of the h, there's a minus in front of the k. So when you look at the signs that actually show up, you want to think opposite. So the value of h is actually -4. I don't know that you want to take the time and actually write that x minus -4 and say the -4 is what comes after the minus. Just think opposite sign. Since there are minuses in the standard form, they have a tendency to change the sign. That's what they do. The k is going to be +2 because you have y minus 2 there. So that's the y coordinate of the center. And r squared equals 25. R's got to be a positive length, so what's the positive square root of 25? 5. So r equals 5. So just like that, we know the center is -4, 2, and the radius length is 5. That's the information that we're looking for. So it asks for the center first.
Is it going to be that same format with every problem, just the opposites of those two? For the most part?
Yes. Now sometimes it takes some work to put it in standard form. You have to complete the square a couple of times to get it to standard form.
That was like, you look at that and you're like, ugh, about the work involved, and that was like nothing.
All right. Yeah, this is just kind of a warm-up example. They get a little worse than this, but maybe the next one won't be worse than this. This one's nice. The only thing that's worse about this is that the radius length is an irrational number. I'm going to have to use a radical to represent it. Otherwise, it's kind of nice.
So it would be -5 and -1 for the center?
Yes. -5, -1 for the center. And h equals -5. K equals -1. R squared equals 23. So R is the positive square root of 23. Let's see how it wants it. Type in the center first. -5, -1. Oops, sorry about that. -5, -1. And simplify your answer. Type an exact answer using radicals as needed. So
square root of
23.
Infinite sense, you're just going to have us use radical form?
Let me think. It will be open response. Will not be multiple choice. So there could be some flexibility there. I may use TestGen to generate the test. If it's a radical, Most likely it will ask you to express it as an exact answer using a radical, but it's the kind of thing that if it doesn't specifically say that, I would accept either one. If you want to punch it up on a calculator, round it to the 10th place, that should also be fine, unless it specifically says one way or the other. But I don't know that when I'm making out the test, I'll remember this conversation. So I hesitate to say, just be able to do it both ways and read the directions carefully. Oops, did not mean to do that. Question 3. Find here we go, the other direction. Questions 1 and 2, we had the equation. Had to look at the equation and find information, the center and the radius length. Here, we've got the center and the radius length, and we need to write down an equation of this circle.
So would it be x minus 1 squared plus y equals 4?
Almost exactly. What would you change that I might not have liked the first time?
I didn't include the 0 in there.
I think you did not square the y.
Oh.
Otherwise, it looks great. Because it would be y minus 0, quantity squared. So y squared would have done it. And you've got your 2 squared on the right-hand side. Otherwise, it's perfect. So x minus 1 quantity squared plus y squared equals 4. That will be the equation of the circle. Oh, the graph. The graph. Now, if you looked in the video, it's a little bit time-consuming to come up with this graph. The center is a good reference point, but then what I do is I take the radius length and I kind of put a little open circle, the center of the circle, and then go that many units to the right, that many units to the left, back to the center, that many units below the center, and that many units above the center, and then connect the 4 dots with something that looks like a circle. That's kind of my approach to drawing the graph of a circle freehand. So if we just find the one that has 1, 0 as the center, is there more than one that has 1, 0 as the center? Possibly.
Yeah.
What about this one? That has 1, 0 as the center. What is the radius length of this circle?
4. Or no, 2.
It looks like it might be 1.4 something. I think what they've tried to do is draw it so that the radius length is the square root of 2. Thinking that we'll think that. I don't know why we would think that, but anyway, I don't think this is the correct answer. What about this? Because it tells us the radius is 2. So does this look like the radius is 2?
Yes.
Yeah, center, you go 2 units to the right, 2 units up, 2 units to the left, 2 units down. So that looks like it would work a lot better. Good. All right. More multiple choice. Find an equation of the circle having the given center and radius length. So negative 1, 4. It's got to be either C or D, huh? Because you want x plus 1 quantity squared.
It's going to be D.
Well, I'm
Square root. Square 10.
got to take the square root of 10 and square it to get 10. So it's got to be D. Yeah. Fine. More multiple choice. The center of a circle and a point on the circle are given. Write the equation of the circle in standard form. So the center is negative 1, negative 5. Bummer. It's got to be, it can't be A, it can't be C, and it can't be D. But the real work to this problem is calculating the radius length. That's the whole point of not telling you the radius length, getting you to calculate the radius length. So we know the answer, but how could we calculate the radius length if we had to?
Well, they just gave it the distance formula.
You just look, there it is. Oh, it must be the square root of 13. Or is it the square root of 5? What?
Are you going to make us do the work anyways?
Well, I'm going to make myself do the work anyway.
Okay.
Let's see. So you use the distance formula, exactly, yeah. D equals the square root of, call this one x sub 1, y sub 1, call this one x sub 2, y sub 2. It's going to be negative 3 minus negative 1 quantity squared plus negative 2 minus negative 5 quantity squared. So D equals, we'll take the square root of all that, the square root of, oh, ouch, is that negative 2 quantity squared? And this is, shame on me for skipping steps here. That is positive 3, isn't it? Negative 2 plus positive 5 is 3. Square that. So D equals the square root of whatever 4 plus 9 is.
13.
That is the square root of 13. And I use D there for the distance formula. Of course, what I'm going for is R. That's the distance between the center and the radius length. So R is the square root of 13. And you've got negative 1, negative 5 as the center. So x plus 1 quantity squared plus y plus 5 quantity squared equals the square root of 13 quantity squared. I wonder why they even put this as a possible option. I guess interchange the role of x and y, but I don't know how many of us that's really gonna fool. It's B, right? Yeah. Yeah, I need some better wrong answers there. 6. Ouch. Okay, this is the challenging one because the equation is not in standard form. It's not in standard form. It is very difficult to look at it, make a casual glance. With practice and familiarity with this sort of thing, you can kind of figure out what the x and y coordinates of the center are at a casual glance here. The radius length, though, there are some mathematical arithmetic gymnastics that have to be performed to figure that out. So let's set this up so we can complete the square. Okay. Take the x squared term and the x term, put them together, or adjacent to each other, and write plus an empty space. Plus y squared plus 2y, and then plus another empty space. Those are the two squares that we need to complete. And the 33 is in the way. So I'm going to subtract 33 from both sides. And then whatever we put in those boxes on the left-hand side, we must also add to the right-hand side. So standard procedure here. We're going to add something to the x squared minus 12x. What do we add to the x squared minus 12x?
Positive 144.
Positive. Well, it's a two-step process for completing the square. First, you take half of the negative 12. Yes, you get negative 6. And then you square the negative 6, and you get 36. And then you write down the 36 there, and the 36 there. Let's pause for a moment and consider what that 36 does. See, what we want to be able to do is write this as the square of some binomial. It's going to be x minus something times x minus something. And that something, you had to multiply by itself to get this number right here, and you have to add it to itself to get this number right here. So that's the number that fits the bill. So you put a 6 there and a 6 there. That way, negative 6 times negative 6 gives you 36, and then negative 6x plus negative 6x will give you the negative 12x. So that's kind of the idea. And if we follow the two-step process of taking half of the negative 12 and then squaring the result, we get the number that we can make a perfect square trinomial out of this with. What's half of 2? 1. What's 1 squared? 1. So we add 1 there, we add 1 there, and this one is going to be y plus 1, quantity squared. And it equals whatever negative 33 plus 36 plus 1 is. That's 4. It's nice when it's a perfect square. It doesn't have to be a perfect square, but it's nice when it is. So now it's in standard form. And much easier to look at this and see the coordinates of the center and the radius length. The center, everyone feel good about 6, negative 1? And radius length, r squared equals 4. So r equals 2. So 6, negative 1, and the radius length 2.